Now we're going to look at a couple of applications of inequalities in modeling. Let's look at this example where the gas mileage G of a particular vehicle is given in terms of the velocity of the vehicle. And we have a formula for it. G is 10 plus 0.9 times the speed minus 0.01 times the speed squared. And this works as long as the velocity is between 10 miles per hour and 45 miles per hour. Outside of that range, this formula is no longer a good model for the gas mileage for this vehicle. And the question is, for what range of speeds is the vehicle's mileage 30 miles per gallon or better? So the first thing to do is translate this question into mathematical format, and the question is, when is G greater than or equal to 30? And of course, since we only have the model for speeds between 10 and 45 miles per hour, we're looking for solutions to the inequality G greater than or equal to 30 and V between 10 and 45. So we get two equations. We want to solve 10 plus 0.9V minus 0.01V squared greater than or equal to 30 and V between 10 and 45. So our question is, can we solve these simultaneous equations? Well, yes, we can. This one's going to be a quadratic, and this one's already giving us an interval for values of V. So here I'm going to bring this 30 over to the left-hand side, and I get 10 minus 30 plus 0.9V minus 0.01V squared greater than or equal to 0. And I want those values of V, which are between 10 and 45, which satisfy that inequality. So I want minus 20 plus 0.9V minus 0.01V squared greater than or equal to 0, and V between 10 and 45. Now I'm going to multiply this by 100 just to get rid of that 0.01. So I get minus 2000 plus 90V minus V squared greater than or equal to 0. And now I'm going to multiply across by a minus just to make the coefficient of V squared positive. So in this case, I'm going to get 2000 minus 90V plus V squared. And because I'm multiplying across by a minus, the greater than or equals changes to less than or equals. Now I have two equivalent inequalities to the first ones, and they should be relatively easy to solve. So this is V squared minus 90V plus 2000 less than or equal to 0, and 10 less than or equal to V, which is less than or equal to 45. The next step is to factor this, and actually the factors are relatively easy to see. We need two numbers which add to negative 90, and when we multiply them we get 2000. So negative 50 and negative 40 work. And now we have the factors are 0 at 40 and 50, and we have V minus 50 is positive for V bigger than 50, negative for v less than 50, and v minus 40 is positive here, negative here. So we have v minus 50 times v minus 40 is less than or equal to 0 for, here it's positive, here it's negative, and here it's positive again. So it's true for speeds between 40 and 50, and I'm looking for speeds that are also between 10 and 45. So the solution is the range of speeds for which this vehicle gives a mileage of 30 miles per gallon or better is for v between 40 and 45. So the solution set to this equation is v between 40 and 50, and this one for v between 10 and 45, and so the intersection is from 40 to 50 intersected with 10 to 45, and that's everything from 40 to 45. So this is true for speeds in the range 40 less than or equal to v, which is less than or equal to 45 miles per hour. And we're done. Here's another example of modeling with inequalities that we often encounter when we're looking at optimization problems. So suppose a gardener has 120 feet of fence and she wants to enclose a rectangular garden, and the area enclosed should be fixed at 800 square feet. And what range of values are possible for the length of her garden? And you might want to try this. The best approach is to draw a picture and create variables, in particular a variable for the length, and see what constraints you have, and then figure out the possible solution set. So this garden will be rectangular, and it will have a particular length L, and of course, since it's a rectangle, the length of the opposing side will also be L, and it will also have a width W. And so the question is, for this particular picture, what range of values are possible for L? Well, what are the constraints in our behavior here? Certainly the amount of fence available is a constraint. So the amount, the perimeter of this garden has length 2L plus 2W, and that must be less than or equal to the amount of fence available, which is 120 feet. And the other constraint is that the area inside here should be exactly 800 square feet. So that's the other constraint in our behavior. The area is 800 square feet. And so what range of values are possible for L given these two constraints? And now notice that this constraint gives us a relationship between L and W, because the area is going to be the length times the width. And that means that L times W must be 800. And that means I can write W in terms of L. So W is 800 divided by L. So now our constraint number 1 gives us that 2 times L plus 2 times W must be less than or equal to 120. And what does this say about L? Well, we should be able to figure out a range of values for L here if we take everything to the left-hand side and use our analysis from rational functions. So this tells us that 2L plus 2 times 800 over L minus 120 must be less than or equal to 0. And now I'm going to multiply across by L, and I'll get 2L squared plus 1600 minus 120L is less than or equal to 0. And now I'm going to pull out that 2, and I get 2 times L squared plus the 800 minus 60L is less than or equal to 0. And dividing across by 2, I get an equivalent constraint, L squared plus 800 minus 60L less than or equal to 0. So I'd like to find the factors of this and figure out where that's less than or equal to 0. Well, the two factors are easy enough to figure out. I need two numbers so that when I multiply them I get 800, and when I add them I get negative 60. So if you think about it for a bit, negative 40 and negative 20 will work, and you can always use the quadratic equation to figure this out. So where is this quantity less than 0? Well, I have 20 will play a role in the answer, and so will 40. The intervals where this does not change sign, 40 to infinity, 20 to 40, and negative infinity to 20. And the sign of L minus 20 is positive on these two, negative for x less than 20. L minus 40 is positive here, negative here, and negative here. And then their product, L minus 20 times L minus 40, is going to be positive here, and positive here. So this expression is less than or equal to 0 when 20 is less than or equal to L, which is less than or equal to 40. And I'm including the 20 and 40 because the expression is equal to 0 at those points. So therefore L, which is given in feet, must be 20 feet is less than or equal to L, which is less than or equal to 40 feet. So this is the range of possibilities for this gardener for the length of this rectangle. Of course, there was one other constraint there which I didn't mention, and it wasn't really necessary, but the L would have to be greater than 0 in this case. But that doesn't play a role, that constraint doesn't play a role in the final answer, because the solution to this equation is already something greater than or equal to 0.